Hey everybody, we're going to start talking about more on the ventilation system. It's a very important part of air conditioning. Of course, you don't move their air around, whether it be interior to the passenger compartment or also talking when we get into the airflow, which we'll be talking when we get more into the condensers and stuff like that. All right, so let's go ahead and get started. All right, we should be able to see it now. All right, excellent. Okay, and we're going to go ahead and get it going. All right. All right, so like always, kind of go over a few things. We're going to talk about getting into, the outside air being circulated in because we can't have it completely closed off. We could have a possible exhaust leak and might cause a problem too. So we want to make sure we got good airflow coming in, and also we have the inside air moving around, and the inlet ducts we'll get into, and temperature blending, and then mode doors. Uh, so we're we're not just talking only air conditioning. We're also talking about what I like to call air management, where we get into heat. When it's cold outside, we want to be comfortable. When it's hot outside, we want to have that air conditioning. And then when it's got like nice neutral air, we can actually turn it to where it's just outside air coming in. And of course, you're not defogging or defrosting the inside windshield, and then getting into the control head. We'll go into that too. So this is just an example of a dash. Your dash could be different, or a car you're working on could be a little bit different too. But it does show some basics on, of course, your instrument panel where your steering wheel is, which is a lot of times it's looking like it's going away, especially when we get into autonomous cars and all. Then we have the defrosting ducts, and then we have the air conditioning vents coming out, going, well, sometimes they're called registers, coming out and going towards your face, or we're going to direct it up, or we're going to direct it down, like on the heater floor down at the bottom here. And then, of course, we have the fan, or the axle, the blower motor also, and then your evaporator, which could be in different spots. Now, don't take it as this is the only spot it could be, because I've seen some over by the glove box, I've seen them here, I've seen them like all over the place. So it just depends. And then if you have rear air, like on some of your SUVs and your vans and stuff, you might have that too. But your airflow is really controlled by the blower motor. The blower motor it actually circulates the air, and that blower motor is in multi-speed. We used to have 2 speeds, 3 speeds, and now we have a multi-speed where it depends on the demand. You can just plug in what temperature you want, and depending on what kind of demand, you can actually kind of oscillate that speed up to higher speeds or lower speeds like that. So uh, most systems, use like flap doors too. So this is where we start, getting into the blend, and we get it to where we can close off certain doors to get better performance of what we want on this whole, directing the air, or we want a blend of a hot and cold, or we want directly only hot, or we just want directly only cold. So the blend doors are very important, and they've actually changed over the years also. And then we have the temp controls, where it kind of gives you that, like I said before, it could be a program in, it could be a dial type control. It really depends on what kind of system you have. So this is an example of this is more of a zone control, or a multi control system, where you would have, like the passenger side could actually adjust their temperature, where you would have your temperature as a driver at a actual temperature too. So, and you can get to where they're just totally digital, where they're just total push button, and like in my Forerunner, it's just a basic type. So it's just everybody gets the same temperature, it doesn't matter. Whereas on my Ionic, then I actually can uh, push a button and it just directs towards me and it eliminates the passenger side. Or I can push the button again and it'll be both sides getting, but the passenger has the option of actually dialing in a different temperature than what I might have. And this is something that's, you know, and the airflow can change too along that way also. So blend doors, there's different modes, and we're going to get into this in a little bit here. So this is kind of just a picture of what it might look like. So here's our blower motor down here. This is the door for the outside air coming in, or I should say the recirc door, or recirculation. So this one, there's another door over here for the, well, I should say a lot of them have a door, sometimes it's just free flowing. But here is a door coming in to bring in the inside temperature air in, and here's my blower motor, and then I can actually go across like my evaporator, or I can actually direct it to go through the condenser. I'm sorry, the evaporator here, evaporator, then my heater core, and I can actually blend it across, or I can make it a direct flow across that way too. And this will be going down, and this defrost up. So we can have it different directions. And this is, I like this picture probably a lot more than I do like the last one, but it gives you the kind of idea of how everything's put, you know, depending how they stack it in there is how they can actually direct that airflow also. So this is just a good picture of here the air is coming across, here's my defrost, this is my fresh air coming from the outside, and then I have my heater core and then my evaporator over here. Now this is an old style vacuum operated too, and we'll get into that a little bit later on, because most of your vehicles will actually have electric doors, and that makes it a lot more precise. A little bit of a pain when setting them up if you don't know how to do it, but they are very precise and they move a lot faster too. So this is what an AC housing would look like. This is the outside. I have someone, the AC housings, I'll have you all take apart and look inside. You can see some of the pieces and all. And I do have some that you can actually see where the actual expansion valve is at also. It makes it a little bit easier to see it that way. So I keep those boxes around just for, you know, kind of exploring type thing. This is, you know, here is a recirculation door, and you'll notice this guy right here. This is what's really one of the things that you're going to be seeing is little temperature sensors going across. Now these are thermistors that actually send feedback to the AC module. Basically, we're having the computer adjust everything too. So this is one of the things you'll see. They can be stacked in different places, so just keep that in mind also. And right down here, you can actually see where the blend door is actually put in place, and we'll just have different doors as we go across. So right now the blend door is over here, and here we have a mode door. Okay, so they actually bring it across. So your blend, I'm sorry, it was over here, and then we actually have a mode door, and then we have that dual zone control. So that has two different ductings going out. So we have one here that is part of that box to actually be able to have one side one temperature, one side another temperature like that. Now, some of the things that you really want to look for when you start getting airflow problems is almost all cars nowadays, and I would say a good 90% of them now have an air filter in them. These are filters to filter from the outside air in, and also the inside. It just brings it across this right after and sometimes before the blower motor. usually after the blower motor, and it kind of allows air to be circulated that way. And this is a great part that they put into it, because before we just had outside air coming right in, and you had your pollens, you had all these, if there was dirt outside, you're going through a dusty area. Let's say you're going across up the 5 freeway and the 99, and you go through a dust storm, all that stuff's coming inside. This is what helps filter a lot of that stuff out. So this is a very small micron. You can get these in all kinds of, like I say, flavors. You could actually have Febreze, you could have different scents. They make them standard types also, and they make them a little bit finer. If you have allergy problems, they make some, not all models, but some with a different filter to them. And this is what it looks like. This is definitely needs to be changed. You can see how it's already got dirt accumulated on it. That dark color sometimes could just, but you can see the dirt here. See the I'm not looking so much on the dark color of it, but look at the actual debris that's inside of it. The thing is, a lot of them have charcoal to them, and actually helps remove some of the odor. And early on, we did have a lot of problems with odors accumulating. We'll get into that as we go across when we start talking about the drains and stuff like that too. But this is kind of what it should look like. It's pretty much cleared out, and this looks really like almost a brand new one. You'll notice it has some foam around the edges, so it might make sure it seals, so it actually directs all the airflow across that filter itself. Now the case parts have different parts of them. There's the plenum part of it that actually connects all the air outlets in, and inlets and outlets, I should say, and that's made of plastic. Now early on we did have some really early stuff. I'm talking about in the 60s, we actually had some metal boxes. Not very popular, but now we have mainly plastic, and it'll be across. And again, we want to keep as much water and moisture out. We just let it out to the atmosphere. We would actually get airflow going, and it might pick up a little bit of water if it is actually raining. I remember my old 63 had a little door on the side, and it was basically a door on the side. And if you went through a puddle, you got quite a bit of water that way also. But this is typical of an actually housing, and you can see where the blower motor is at. It's kind of similar to before, but here is that condensation or drain, and we'll get into a little more onto that. And then here's your refrigerant lines going in, and then here's the plastic part of it, and here's the heater core lines. So this is just a different way of doing it. So you actually have your defrost vent over here also. So then you have the ducting, then you have your air doors, that actually, your normal positions going on, up and down, and then your ducting that actually moves it from the windshield to maybe to shut off the recirculation doors, cancel out as much of the outside and inside doors. So this is the inside air, I should put it that way. So this is, just some of the things that are part of it. Now we do have like the fresh air door, the recirculation doors, and the outside air door also. This is just parts of what's in the plenum. And then we have the blend doors, where you actually the temperature blend. It can mix the air, the temperature door, blend door, diverter door, and then we have a bypass door. It could be, now, depending on what kind of model you may have a very basic one, or you might have multi-doors, and you might add on more doors when it comes to your zone controls. There's been a few vans that I've worked on where they actually had up front doors, and then there was a vent door back here by the passengers, and then there was actually more in the back. So you could have multi-type doors. If you get into some of the fans that have been converted. You might even have vents going from above that can be canceled out also. So it just really depends on what kind of system you have. So again, kind of going over it again. So you have outlets. All these outlets. Where it be towards your face, you can cancel them out a lot of times. And then you have the center. And then you actually have the passenger. Then you have your directed flow, and then you can actually have temperature across that. And of course, defrosters going up. And just keep this in mind too when you're talking about defrost. And one of the big things on that is your air conditioner, for defroster to work properly, you need to have your air conditioner working properly, because part of what the air conditioner does is dehumidify, and that's the fastest way to actually help with defrosting your windshield. It takes it kind of dries off that moisture, and you're going to use like the heater and the air conditioner at the same time. Sounds counterproductive, but that's how it works the best. Then mode doors, where is it going to go? Is it to the front panel? Then is it going up, down? And then you have your AC, which is normal, and it has a little bit of outside air. And then you have your maximum AC, where it's going to cut down the outside air and it's kind of recirculate it. So it's going to be a big portion, I would say about 90%, all in the inside. And then of course you have your heat, where it actually goes to the floor. Now again, you can actually mix that up a bit. You can actually direct it a lot of times to the face also. So it just really depends on what kind of vehicle you really have. So max heat, bi-level, defrost. So all these doors have to work properly. So let's get into some of the doors on your AC system. Now this is one style here. So you notice it's got the inside air, and this is your max or your recirculation type AC. Watch your doors here. So here I have nothing coming up from the out. Okay, so I'm coming in, inside air, going through the blower motor here, which really what they don't show you is you're going to either have a filter here or you're going to have a filter here, and it goes directly across the evaporator. And notice how it directs it away from the heater core. Now you could have an additional thing too when it goes to air conditioning. Depending on what you have, you can actually have either a electronic or a mechanical type of heater. Here, I should say, coolant flow to the heater core to actually block that off too. It just really depends on the system you have. You got to kind of map it down out the system. So here I have maximum recirculation, so as you can see how it just comes from the inside air, kind of blocks off as much as possible on the outside air, and then we go across the actual evaporator and then right out to the registers. Then we have this, kind of like a normal air conditioning. So we have outside air coming in. So we have outside air going across, nothing coming from the inside. We're just blowing out cold air, and you will have a little bit of heater movement in here. It sounds again like it's not going to work right, but this is how we have our normal type of AC going on. Again, this could be turned off electronically or mechanically, either from a vacuum pod or something like that too. All right, so we got our normal. Now we're going to the bi-level. So we've actually still have the air conditioning on. We're going across the evaporator. We've closed off the heater core, and then we're going to the heat floor, and then we're going to the face. So we're at a bi-level type one right now. And then we could go for the heat. Again, remember the evaporator helps with the humidity, dehumidifying. So we're going across here. We've probably turned off the actual air conditioning at this time because it's just going for heat. So it's blowing across here, but you're really not picking up a lot of cool air, if any. And then we're going into the heater, going on down to the floor. We're not coming out the, if we turned on the bi-level, we could have it too, but this is where we're actually just going to the heater part of it. Remember, heat rises. And then we have the defrost, and notice how this works. We actually brought in the outside air, and then we go into the air conditioning, because we're going to use that to defrost. We're blocking, we're actually diverting. See, we still have a little bit of movement here, but we're going through here, going to the floor, and then we're actually going up through the defrost. All right? So just kind of doing that again, but in a different type of picture here. We have the temp mode. See, we're going full AC and full cold. Okay, so blower is going across, here is going across my evaporator. And then we're going across the heater part, so it's going through the heater core. And then we're going through a bi-level or a mixed type. All right, this is just in the looking at the blend doors. So we can actually blend it across. We can actually change our door movement here, blower motor, evaporator, and we got our movement going here. And this is showing a different one altogether too. And depending on the type of system you have, it can actually go back to the passengers. It could be through the floor, it could, for the heat, or it could be for the air conditioning. We can actually go right from the center console all the way back. Jaguars are famous for this. I've actually serviced a few of them that actually have this type of system also. So they'll actually have their little registers right down the center there, right about here, are my rear vents. And then we have non-electrical type old systems. I don't think you're going to see too many of them anymore unless you're working on some old stuff. They had an actually mechanical cable, or they had a vacuum door operated to them also. And this is kind of one, sometimes they call them vacuum pods, vacuum motors. So we have this one that actually has one here, and then we have another one here. And you'll notice the color of the vacuum hoses. There was some issues with these. If you lost vacuum, you wouldn't, the doors wouldn't move properly. Some are push pull. Some of them, they'd have a hole in the diaphragm. The control head, as they called it, where all the vacuum controls would go, they would actually have a leak. Some of the early ones had a master AC vacuum motor to them that actually had could have vacuum leak issues, and it could be something as simple as a vacuum reservoir. And so it was there's all kinds of things that went wrong, and you had to know how they worked so you could actually correct them properly. So these, and then there was the electronic ones that are actually a little bit better. They're actually using, well, I should say a lot better. They're using motors and really getting into the nitty gritty of controlling much finer and more direct. But not saying that they can't have problems too. These are typically two-wire, motors that actually rotated back and forth. You could have one that had an actuator, kind of almost like a sense of where the door was, and that's what you're pretty much going to be now, because it's giving feedback to a module for the HVAC. So this is where we're really at right now, which really works a lot better. And then you have the 5-wire, so the motor, then you have a potentiometer that actually gives a more precise where's my door sitting at. And these have to be calibrated, especially when you're putting a brand new motor actuator in, I should say motor and potentiometer together. If you don't, they won't know its location. You're going to get all kinds of flashing on the dash. This is one of the dead giveaways that it's lost sync too. So, um, calibration, it's not that as hard as it sounds. There are different calibration for different types of systems. It's just you need to know how. A lot of times if there's if you have a bad motor, you're going to set a code in the body control module, and then you're going to have to go and figure out what's wrong. Is it a bad wire? Is it a bad ground? Is it a bad power? Is it a bad motor? And then you replace it, and then you're going to have to go through in the calibration mode. And I recommend that you go through the steps that the manufacturer tells you to do. This is going to be a generic type of calibration. So basically, clear the codes, which is your DDC, diagnostic trouble codes, that are in directly. Now, I'm not talking about the powertrain. I'm talking about the actual codes for the air conditioning HVAC. And then you're going to turn the switch on, switch to the off position, and install the replacement actuator. So you're going through the steps and like that, and all mechanical. It could be I've seen some air door, the actuator doors break off. Also, so you don't know until you tear a lot of this apart. Sometimes it'll set a code for a bad actuator, and then all of a sudden you go in there and the door's ripped off of it. It can happen, and I've seen some things too, folks, where it's like a pencil got down inside and jammed that door, and then it caused a problem to where it would flash. There's nothing wrong with the motor or the door. It's just there's a pencil wedge down inside there. That's why it's not a great idea to have a bunch of debris, or I should say, like pencils, stuff up on your dash. We all want to have our fun stuff, but if that stuff gets down inside, again, you could actually have a problem. It's one of the things I look for when I see something start flashing. I start looking at the dash to see if maybe somebody if they have a bunch of stuff up there, maybe there's something that went down into ducting, and I let my customer know a lot, at the very beginning like that. Back to it. So then we go to the start engine and select mode recalibration program in the scan tool. Sometimes if you get some of the earlier systems, it's not that way they do. You got to actually go through and almost have the whole air box out, plugged in to the controls, and then you have to actually do the steps of bringing everything to center, and then go through the part of turn the key on. Sometimes you turn them on, and then you have to hit the buttons, and then you have to go that way too. So then this one you actually do it with the scan tool, and then you verify there's no trouble codes afterwards have been set, and then boom, you're good to go. This is a 2 wire actuator here, so this has the 2 wires to it, and it's the real really basic one. There is again, we could have one with actually a potentiometer involved in it, and then we'll have a module involved in it also, and it all depends on what kind of system you have. So kind of similar to what we use it's very, very similar to what we use in like throttle position sensors and different types of sensors. So this is one style, and then we also have the other style that it gets a little more complicated. These are the 5 wire systems, and they are very, very precise. And this is this is going to be one type of a module involved in it also. So it can actually go right to the control head. You tell it, hey, I just want it at 74 degrees or 72, and it takes over from there, and your module will actually, which is sometimes is control right into the control head too. And this is kind of has a little feedback circuit. So when it gets to that point where it's to that temperature, it's going to kind of throttle it back. And if it gets a little bit warmer, it's going to throttle it up to where it gets cooler. And if maybe you want it warm inside, warmer, I should say, and it's going to actually adjust that temperature until it's exactly where you want it to be. And the blower motor, they are, multi-speed. They can be adjusted to different types of speeds now. Like I said before, they were a switch that actually did like 3 positions or 2 positions. You maybe have a really fancy one with 4 positions on it, but they went to more electronic. And this is what your blower motor looks like. This is a little, vent for the case also to keep it the motor cool. And then here's your electric connector, and they call it a squirrel cage. It's a little cage that actually directs it. And these are usually plastic. The old ones were metal. They were definitely knuckle scrapers. But you want to actually, I would recommend. This is just me. So you can actually just buy the blower motor separately, just the electrical part of it. I would actually buy it with the cage on it, because sometimes when you take them apart, the cages are already cracked or they're already broke. You don't want to do it over again. And then over here we actually have, this is a electrical type, electronic I should say, a speed controller. And you notice it has a big old heat sink on it. This guy is going to keep, because these really get super warm. Don't leave them out and try to test them that way, because if we don't have airflow across here, it can actually destroy these. The old ones were just a set of resistors. These were a resistor pack. I believe I still have some, and I'll show them to you in class. But these actually were really good. Well, let's put it this way, I could actually fix a few of these. The electronic ones, you're just pretty much just going to throw them away if they go bad. And you really need to know how to diagnose this to make sure that they are. And usually they set a code. Usually they do, and there's a procedure for doing it. Again, always follow the procedure the manufacturer has in place. All right. Last off, I just wanted to kind of close this up with a little bit of what we've covered. We covered quite a bit, but this is just a recap. So airflow, it goes right through the case, and it goes through the evaporator. We have that airflow going through the evaporator. We got it going through the heater core, depending on what kind of demand we have for it. Do we want it hot or we want it cold? And then we have the blower motors in place. The AC it also has the filter inside there that actually helps with keeping the particulate out, all this dust and dirt that might be in here, and it helps reduce the amount of odor in places. This is, we'll get more into, talking about odors and stuff like that as we go along, and we want to make sure that we make our customers as comfortable as possible, whether it's you're working on your car or you actually have a customer's car that you're working on. So hopefully this is beneficial, and if you have any questions, feel free to reach out to me, and I'll answer your questions as quickly as I can. All right, take care, and I'll talk to you soon. All right, let's close this off. Bye for now.